So we've talked about needs and requirements and how we use business analysis and requirements analysis to translate between those needs and requirements at various levels. Let us now look at the process that relates to that translation in a little bit more detail. But first, we'll start with some definitions that will assist us. The first thing we have to recognise is that the terms such as system and system element are actually level specific. So we need a term that can apply to any level or to any single thing at any of those levels. So first we define an entity as a single thing to which a need or requirement refers, and that could be an enterprise, a business unit, a system, or a system element, and that could be a product, a process, a human, or an organisation. That entity has a need, and so we talk of a need as the result of a formal transformation of one of more of the concepts that we talk about for an entity into some form of agreed expectation for that entity to perform some function or possess some quality. And of course, that's always within some specified constraints. So what then is a requirement? Well, a requirement is the result of a formal transformation of one or more needs into an agreed to obligation for an entity to perform some function or possess some quality, and again within some specified constraints. Now, it's common in systems engineering to refer to two major categories of requirement. The first is a functional requirement, and as its name implies, it means a function, something that the system should do or something it should provide. The remaining types of requirements are generally called non-functional requirements, and they are wide and varied, but they refer to properties, qualities, or attributes that the system must possess, so some colour, for example, or some shape. It might also refer to some condition that the system must meet, or some constraint under which it must operate, or in fact be developed. One type of requirement that's commonly included as a non-functional requirement is called a constraint. And some people even separate constraints out, so they say that there are functional, non-functional and constraints. But it's common, and here we'll include it as one of the non-functional requirements. Either way, a constraint is some restriction or some bound, something under which the system should operate, or something that places a constraint on the way in which the system is to be developed. As I said, constraints are most commonly listed as a category of non-functional requirements, but some individuals and some companies list them separately. Each statement of requirement is not written in isolation, but it needs to be supported by a number of other statements. First, there are performance statements, verification statements, and rationale statements supporting each of the requirements, and we'll look at each of those in a little bit more detail shortly. We must also include definitions of other systems with which the system must integrate or with which it must interface, and these are what we later on call external interfaces. We might also provide information about the application domain within which the system is to operate, or indeed even about the system itself as it operates within that domain. Now, the requirements in the business requirement specification and the stakeholder requirement specification aren't quite as formal as those in the system requirement specification, but they do have the same structure and they follow the same rules. So let's look in a little bit more detail at performance requirements, verification requirements, and rationale statements. First, performance requirements. Having decided what the system must do, the designer must now determine how well it must perform each of those functional requirements. It's a good discipline to ensure that every time we write a functional requirement, at least one corresponding performance statement is made. Now, most of the operational functions will have an obvious performance parameter associated with them, for example, speed, accuracy, endurance, acceleration, and so on. Even though we've added a performance requirement to our functional requirement, the definition is still not complete until we've added a verification requirement. So each time we articulate a function with an appropriate performance statement, it's good practice to add a corresponding verification statement. That is, how is it that we will know that the system meets the function and meets the performance? Now, it's often difficult to write verification statements for system-level functions, but the discipline of doing so is very important, since there is little point in continuing by stating a function without understanding how it is we're going to test it. An additional benefit, of course, of writing such statements at this level is that our test plans become much easier to write later because we've already, as we wrote each function, begun to consider the tests that might be associated with it at any of the levels. And that means that our testing regime or our testing plans and procedures are beginning to be developed as we develop the functional, performance and verification architecture as we move down the requirements tree. The third statement to add to a requirement statement in the set of what we call a requirement expression is the rationale. Now, the rationale is very important because it articulates the reason why the requirement exists. The rationale might record the design decision which leads to the requirement. It might record the assumptions behind the requirement, or something as simple as just the logic for why that number was chosen, or why, for example, a number was chosen to 2 decimal places, or why it was rounded up to be a whole number. Anything really that will provide some guidance to lower level designers is a very useful rationale so that they understand why the requirement's being asked for in the first place. A requirement should not really be accepted until the rationale is well understood, largely because if we can't explain the rationale, we probably really ought not to include the requirement. Now, as well as the broad categories of functional and non-functional, there are lots of other adjectives used to describe the nature of a requirement. So you'll often hear reference to things like operational requirements, stakeholder requirements, environmental requirements, interface requirements, system requirements, regulatory requirements, safety requirements, design requirements, and many, many more categories. Largely, though, these are simply ways in which we might group them so we can make some sensible use of them. In general, it's true, particularly at the system level, that a requirement should be a statement of what, not how. That is, you should say what the system should do rather than how it should do it and force any particular design on a low-level designer. However, this is often too simplistic in practice because it may well be essential the system does a particular thing in a particular way, to be interoperable, for example, with another system or to meet some particular standard. Also, a particular statement is much less easily confused than an abstract statement. So if it's what the upper-level designers want, they should say so and remove any ambiguity. That's also true because the specifiers of the system are often the domain experts. They're therefore probably best placed to state how the system should be developed and how it should operate, rather than leave it to junior designers. So we've talked about needs and requirements. Well, why do we really need them? Well, it should be obvious by now, but there are a number of very important reasons. First, we need them to be able to define the scope of the project. If we don't have them, how else will we know what the system was to do? Then, we need to ensure that everyone involved has had their input and all the various points of view have been reconciled. The only way to do that is to group all the requirements into a balanced set of requirements. We also need to be able to justify any expenditure of funds or any effort by the organisation in meeting the need in terms of being able to meet that endorsed set of requirements. And then, of course, when we're doing the work, we need to be able to report on progress. How do we know how far we are through the project? We need to report back against the set of requirements. And then finally, of course, we won't know whether we're finished until we can tick off each of the requirements. So all in all, we need requirements to be able to describe the project, but also to help us manage the project. Let's now look at some major definitions. We've used some of these terms already in a general sense, but before we do, let's define them a little bit more precisely. A user is someone who's involved in using the system once it's been developed. Strictly speaking, users are part of the system. They're there as part of the other elements of a system, such as materials, facilities, data, software, hardware, and so on. And because they're part of the system, users are sometimes called actors. That is, they play a role as part of developing the functionality of the system. So users will include operators, maintainers, and so on. Now, users work for the customer. The customer is the organisation that's paying for the system to be developed. Within the customer, there is an acquirer, who is the entity that's acquiring the system. Because the users are normally too busy with their operational tasks, they don't have the time, or necessarily the expertise, to acquire new systems. Large customer organisations will therefore most likely have a separate acquisition organisation, that is, separate from the user organisation. And as we said before, the customer is probably not big enough these days to be able to develop the system themselves. So they'll engage with the developer. Now, that developer is the person responsible for developing the products that make up the system. That developer could be in-house, but most likely these days the developer is part of a contractor organisation. And the contractor is the organisation within which the development is conducted, and as we said before, normally therefore under contract with the customer to do the development. We also mentioned a stakeholder, and a stakeholder is anyone that's got the right to influence the requirements, sometimes more generically called anyone that's affected by the system. Users are invariably stakeholders, but other stakeholders may include management, clients, the public, and so on. So we've discussed needs and requirements. Let's now turn to the idea of requirements engineering. Well, we've talked about needs and requirements and the various levels at which they exist. In passing, we made reference to requirements analysis, which is really part of a bigger picture called requirements engineering. As illustrated here, requirements engineering is the formal process through which we move from enterprise strategies down to the system requirements. First, by formally translating the business needs into business requirements, into stakeholder needs and requirements, and then into system requirements. We also saw earlier why we need requirements. Well, why do we need requirements engineering? Well, obviously, if we need to be able to move knowingly between requirement sets, we need a formal process to be able to do that. We need to be able to guarantee that we have a complete set of requirements that's unambiguous, that's complete, that's non-conflicting, and so on. We need to be able to trade off functionality for cost, which implies that we understand all of the things we're required to do, plus their priorities, plus their costs, and so on. And then finally, things will change. So through requirements engineering, we need to be able to manage the changes in requirement for a wide variety of reasons. If you're interested in reading further into the topics we covered in this presentation, you may wish to read the corresponding chapters in the texts associated with the course.